Okay. Um, any questions? So today we're going to learn about 3.3 and hopefully 3.4. Um, 3.3 is piecewise functions. And to graph them, we're going to use Desmos, but first I want to make sure you understand like plugging in values to them. So it's a piecewise function because there's more than one function, and during certain x values, you use certain ones. So this is saying if x is less than or equal to 0, then we use this one. If x is greater than 0, we use this one. So for f of 1, 1 would be here because it's, whoops, here, because it's greater than 0. And so we would use this equation and plug in 1. So it would be 1 cubed plus 2. 1 cubed is 1 plus 2 is 3. F of 0, and then you want to see which one the 0 fits into. Well, this one, that little line under the inequality means equal to. This one doesn't have it. So that would be this one for equal to 0. And so we would plug in here. 0 squared minus 1 is a negative 1. Any questions on that? Okay, go ahead and find f of negative 2. For f of negative 2, are we going to use the top line or the bottom? And you can type it in the chat if you don't want to answer. Should we use the top or the bottom? Anyone?
Top.
Because negative 2 is less than or equal to 0. So we use the top. Negative 2 squared minus 1. Negative 2 squared is a positive 4 minus 1. Do you get 3? Any questions on plugging the values in? Okay. To graph it on Desmos, for the inequality part, you put it in script parentheses. So first I'd put my x squared minus 1. Now, if you want, you can bring a table up like this, or you can use, like for the squared, you use a caret to get it up there. But we can go x squared minus 1. And there's our parabola. But we only want the parabola when x is less than or equal to 0. So we want it from here and then to the left. So if over here we use the script, and it's where the square brackets are next to your p on your calculator, the script, x less than or equal to 0. Notice it only used the 1/2 of the parabola then. It used from 0 and less. So x is less than or equal to 0. Any questions so far? Okay, and then we graph the second one, x. You can use a caret to get into the exponent. The caret is where your 6 is. The only thing is when you do use that, notice it stayed up there. I have to hit the right arrow to get back down. Plus 2. Now I only want x greater than 0, so I'm going to use my script parentheses again. X greater than 0. So that would be this piecewise function. Any questions on the graph? Are you getting it to work for you? The script parenthesis is next to the P on your calculator. You have to hit shift in your square bracket. Exponent, you use a caret, or well, I'm not seeing the y to the, well, there is more functions you can push. No, no, those are sine and cosine. If your keypad didn't come up on here, you just press this here and it'll bring it up. You press it again and it'll bring it down. Any questions on typing it in? Now, notice that if we trace this graph, right here at when x is 0, there's a break in the graph. So that means it's discontinuous at x equals 0. When we get into more of the story problems, it's important to know where it's discontinuous at. We'll get into limits and we'll be checking that. So wherever the graph breaks, it's discontinuous at that x value. Any questions? Okay, let's try another one. So we've tried this one. First, we want to find f of 6, 4, and negative 6. This one is x minus 4 if x is less than 4, 4 minus x if x is greater than or equal to 4. Let me move that out of the way for right now. So find f of 6, f of 4, and f of negative 6. When you get the 3 answers, type them in this order, just the answers. You could separate them by a comma if you want, or space. So I know that people are getting done. For the first one, the 6, using the top or the bottom? Anyone? You can type it in the chat. X is 6, and 6 is greater than or equal to 4. So I use this one. 4 minus X, which is 6, equals a -2. Any questions on that? So quiet. I don't know if it's because it's easy or you're lost and don't want to ask. All right, for 4, well, to decide which one, because we know that 4 is here, it has to be equal to it. This little symbol means equal to. This one doesn't have it. And so it's this one. Because 4 equals 4. We plug it in here. 4 minus X, so 4 minus 4 is 0. Any questions? Plugging in the -6, we'd use the top row because -6 is less than 4. -6 minus 4 is a -10. So any questions on plugging them in and which one to use? Okay, go ahead on Desmos and graph it. So clear the ones that are there. And put these two. Should be getting an upside down V. Is everyone getting that? Notice that unlike the other one where it was broke here, this one is continuous because we can trace and not have to pick up our pencil. It keeps going. Because if you plug 4 into both of these, you get the same answer. So where the one end of the other one fills in. So this one would be continuous. Any questions on those? Number 3. Any questions on the graph? Okay. For number 3, we want the formula that gives the wind chill factor for a 60-degree Fahrenheit temperature and a wind with velocity V in miles per hour is given here. So this is 60 degrees if your velocity is between 0 and 4 miles per hour. If it's including the 4 to 55.9 inclusive, then use this formula to find how cold it is. And then if V is greater than 55.9, it's 41 degrees. So depending on how strong the wind is, the colder it will feel, even though it's a 60-degree day. But after a certain point, It's only going to feel 41. It won't feel colder than that. So it says find the wind chill factor on a 60-degree day if the wind is 20 miles per hour. Now the wind speed, miles per hour, is V. So we're saying when V is 20, find the wind chill. So you have to decide which one of these 20 falls into. Does 20 fall into the top, the middle, or the bottom? Someone needs to type it in the chat. Which one would the V fall into, the 20 miles per hour? Top, middle, bottom. On a test, the biggest mistake is choosing the wrong one, and so I want to make sure you understand it. Thank you. So it's the middle. Because 20 is between 4 and 55.9. Then you take 20 and plug it in for V. So we have 0.644 times 20 minus 9.518 square root of 20 plus 76.495. Are we getting 46.8? $76,495. Yep. So on a 60-degree day, if the wind is going 20 miles per hour, it will feel like it's 46, almost 47 degrees. Any questions on that? Yeah, let's look at the next one, B. Find the wind chill factor on a 60-degree temperature if the wind is 65 miles per hour. Well, 65 miles per hour is greater than the 55.9. So we know it's here. And if the temperature is greater than if the velocity is greater than 55.9, the temperature is 41. So 65 miles per hour, 60 degrees will feel like 41 degrees. Any questions on that? It really makes a difference when you're talking low temperatures. We had days where the temperature was 5 degrees when we got up in the morning, but the wind was so strong we were at a -10. So any questions on that? Number 4. For non-extreme weather months, the electric company charges $7.10 plus 6.747 cents per kilowatt hour for customers using up to 1200 kilowatt hours and charges 88.06 plus 5.788 cents per kilowatt hour above 1200. Write the function that gives the monthly charge in dollars as a function of the kilowatt hours. So monthly charge. So C for cost, I guess that would work. And they want it in dollars. Now think of these as straight lines. They charge $7.10 plus a cost per kilowatt hour. That's your rate or your slope. And the 710 is your fixed cost. So we want to think of MX plus B. The 710 is a fixed cost. And this is the rate per kilowatt hour, but it's in cents. We need to change it to dollars because they want the cost to be in dollars. So it would be 0.06747 times, we'll use X. So I changed my pennies to dollars. Now you want to do the same thing with the other one. Now this was up to 1200 kilowatt hours. So if it's going up to 1200 kilowatt hours, it would be less than or equal to it. It wouldn't be past it. It's going to stop at 1200. The second one charges $88.06, but then you're only paying 5.788 cents per kilowatt hour. So we'll make this into dollars. It's per kilowatt hour, so it gets times our X, plus our fixed amount, which was the $88.06. This is when X is greater than 1200. Any questions on setting it up? Okay. That would be part A. What is the monthly charge if 960 kilowatt hours is used? Well, X is our kilowatt hours. And so we would look here and see which equation to use. Now, if we only use 960 kilowatt hours, then we would use this one, because that's less than 1200. Then you would just plug it into this equation. So it would be $71.87. Is that what everyone got? Okay, go ahead and find part C. What is the monthly charge if 1,580 kilowatt hours are used? Um, 1580, oops, over here, would be greater than the 1200, so we would use the bottom equation, 0.05788 times the 1580 plus 8806. 179.51. Any questions on that? Any questions? Section 3.4, it's giving you data, and we did use it already to make a linear, like a scatter plot, to make a linear trend line. But you could also make a quadratic trend line and a power function. So remember, when we're looking for the linear one, that would be y equals mx plus b. The quadratic, which is your parabola, is ax squared plus bx plus c. And then the power function or exponential function is y equals ax to the b. Now what this does, if the absolute value of a is between 0 and 1, it decreases this. And if it's greater than 1, it increases. Now, the next chapter will get more into it, but for the most part, Desmos will be doing most of the graphing. But you need to know what they each look like, because then you want to make sure you have the right graph. And this, remember, is just a straight line. And then this is a parabola. Okay. Okay. So for the first one, we want to make a scatter plot. Now don't go to the other functions. Stay on this screen. Let me delete these first. When you need a lot of equations, because we want to find the linear, the power, and the quadratic equation, it's better to put your data in a different way than we were doing. Before, I just wanted you to quickly be able to get the linear regression line. But now, since we want more than one, we'll do it a different way. So to make the scatter plot, this plus sign, you want to hit the plus sign and then go to table. So it's the plus sign and then table. And then we'll enter our table. So we're going to do this table first. So 3, 5, 7, 9. And on the other side, input 4.7, 8.6, 13, and 17. And you see most of your graph. Remember, we can adjust it by hitting the wrench, and we could go, I'm going to go -1 to 10. That's pretty good. And then here I'll go for the y's, -1 to 20. So what I did was I looked at my table and made sure I had something below 3 and above 9, and then below 4.7 and above 17. That way I can see all my points. Kind of looks like a straight line, but it also could be part of a parabola. Any questions on getting the graph? Now, another thing you have to notice they label these x1 and y1. So when you type equation, you need to use x1 and y1. I tried changing it to x and y and it won't let you. So you have to use x1 and y1. Now, click down here where the 2 is. We're going to put y1 instead of equals where your, let's see if they have it on the table. I don't think they do. Where your apostrophe or right next to your 1 is, if you hit shift, it'll give you this little squiggly. So it's at the top left of your keypad. So instead of equals, you want to use this similar or approximate. Now to find the line, remember we said the line was mx, but you have to do x1 plus b. And this is what we used to get when we used the statistics. So if we used a straight line, it's pretty close to the line. R squared is almost 1, and it gives you your equation. Is everyone getting that? So for m, you're getting 2.065 minus x minus 1.565. And that would be your straight line. If we click next to the 3, and we put our y1 again, and then your little squiggly line. Now if we want to do, what did it say? It said to do the power function next, so that's what we'll do. So the power function, remember, is a x1, and then a caret, so that goes into the exponent, and you put your b. That is the purple, or the purple is the straight line. The black line is the exponential. R squared 0.99. So notice the R squared. This one's 0.9992. This one's 0.9995. So this is a little bit better, not much, but the straight line is a little better estimate than the power function. And this would be your equation. So for our linear, y equals 2.065 x minus 1.565. And r squared power function a, and they show you, well, we typed the equation, so you know where to put these. I'm going to round it 1.3, so y equals 1.3x to the b, which is 1.2. And r squared was 0.9992. Is everyone getting those equations? Okay, we can also do the quadratic, which is your parabola. When you do it, remember for these x's, you'll have to put x1. So we'll click on the 4. We're going to put our y1, and then the little squiggly line, and then ax1 caret squared plus bx1 plus c. And that's our red line. And they give us A, B, and C. And notice the r squared. This is the same r squared as we had for the straight line. So y would equal A, which is almost 0, 0.00625 plus 1.99 x minus 1 point, I'm just going to round it to 4. Now on my math lab, make sure you're rounding it however many decimals they say. Same thing with a test. If it doesn't state on a test, then you can round it to whichever you want. Just make sure you round properly. And this r squared was the same. R squared equals 0.9995. So all of these would be good estimates because this is really close to the same. They're almost all 1. Any questions on that? Okay. We're going to go back up to our table and put in different numbers, but we'll leave these equations here and it should adjust to our new points, hopefully. But is there any questions on how I entered all these? Is everyone getting it? Okay. Let's try the second table. So our x's are 1 through 6. 1, 2, 3, 4, 5, 6. And then 4, 9, 11, 21, 32, and 45. And let me fix our windows. Oh, wow. It didn't. Okay. 4. There we go. I don't know why it wasn't. So -1 to 10 is fine. -1 to 50. Any questions on plugging in the values? Notice that these changed. So the straight line is 0.9388 for how accurate it is. Notice the power function is closer, 0.9866. And then the parabola is even closer, 0.9948. So if we had to choose one, the parabola would be the closest. But again, none of them are bad. But you can see the parabola is the red one, and it's going between the dots more than the other two. Any questions on that? Positive. Is everyone getting the points? So if you want, you could always use this, like on the test, if you have to find the linear trend line, or on your project. If you want to use this one instead of statistics, it will give you the same thing. Okay. Page 227, number 31. There was a couple story problems. Should be here. And first one, number 31. Partially because of Americans living longer, the number with Alzheimer's disease and other dementia is projected to grow each year. The table below gives the millions of U.S. citizens with Alzheimer's from 2000 and projected to 2050. Create a scatter plot with the data with X equal to the number of years after 2000 and Y equal to the number of millions Americans with Alzheimer's disease or other dementia. So X is the number of years after 2000, not the actual year. So for this first one, the number of years after 2000, it would be 0. The next one, 2010, would be 10 years after. And then 20 years, 30, and 40, 50. And then on the other side, we put millions. So this is in millions. 4.0, 5.9, 6.8, 8, whoops, 8.7, 11.8, and 14.3. Any questions on plugging the values in? So X is the number of years after 2000. And Y is millions of US citizens with Alzheimer's. Any questions on that part? I am going to fix my units. -1, this is going to 50, so I'm going to make it 55. And this goes to 14, so I'm going to make it 17. Find a quadratic function that models this data. Well, quadratic, that is number 4, the red one, because quadratic is the x squared. And notice the r squared is 0.9926. Any questions on that part? So for our quadratic equation, it would be y equals A is 0.00, I'm going to just go 3 decimals, 0.002 x squared plus 0.098x plus 4.207. So that would be our equation. Is there any questions on writing the equation? I rounded 3 decimal places. And the r squared is 0.99. If we look at the other two, number 3, the black line, is 0.74, so that's not a very good relationship. But the straight line isn't bad, it's 0.97. But the parabola is the better of the 3. Any questions on getting the equation? No, I don't want that one. I want this one. There we go. We graphed the line on it, it automatically did that. How many Americans does the model predict will have Alzheimer's disease or other dementia in 2056? So in 2056, remember X is the number of years after 2000. So what value, if we want 2056, what value should X equal? Remember, X is the years after 2000. So if we take out 2000 years, X would be 56. Which would be an extrapolation because we only went up to 2050 and that's outside of it. Let me plug that in. 002 times 56 squared plus 0.098 times 56 plus 4.207. Let me just plug it in. So I'm getting 15.967, but remember that's in millions. So by 2056, 16 million Americans will have Alzheimer's or dementia, some form of it. Any questions on that? Any questions on using Desmos? So that you could see the red is the parabola. There we go. That's pretty good. Is there any questions? Okay, so practice using Desmos over the weekend. And I guess that's it. Is there any questions?